These are the 11.2 Part 2 notes, and we're going to be looking at the chi-square test for independence. So the chi-square test for independence, how we set up the hypothesis, is there is no association between two categorical variables in the population of interest is your null hypothesis, and your alternative hypothesis is that there is going to be an association between two categorical variables in the population of interest. The conditions for performing a chi-square test for independence are the same as performing any other chi-square test. So again, if we don't know this by now, I just don't know what to tell you. These are what the conditions are. They have to be random. They have to come from either a well-designed random sample or a randomized experiment. When you're sampling without replacement, you need to check that n is less than 1/10 of n, and then you need your large counts condition, that all expected counts are at least 5. This is the summary here of the chi-square test for independence. So again, null hypothesis, there's no association between two categorical variables in the population of interest. And your alternative hypothesis, there is an association between two categorical variables in the population of interest. And we can also write that alternatively, two categorical variables are independent in the population of interest, two categorical variables are not independent in the population of interest for your null and alternative hypothesis. So again, from this point on, it just runs the way that it always runs. You have your actual values that you found from your sample or from your experiment. You figure out what the expected counts are. 9 times out of 10, when we're actually doing this, you're going to be using software to figure out expected counts. You can be using the matrix function on your TI-83. If we don't have that, then we would actually go through, we would use that two-way table. We would do row total times column total divided by chart total in order to figure out what the expected count is there. And then you do the observed minus the expected squared over the expected, and then you add all of those together. You do the summation of every single one of those values to get your chi-square. Once you have your chi-square, you look at your degrees of freedom, you go to your chi-square chart, and you figure out where it's at. You can also use the calculator to do all this for you. We're going to be going over that in class. Again, degrees of freedom works the same way that it worked prior. You do the number of rows minus 1 times the number of columns minus 1, and that gives you the degrees of freedom that you're looking at. I don't think there's anything else that we need to touch on there again, and then again that finds the p-value. All right, so check for understanding. Now we're just going to jump into this. So I'm not going to read the whole thing here. The idea here in this two-way table is that when you buy a franchise, if let's say that you get a franchise such as McDonald's or Starbucks or whatever, there are two types of franchises that you can have. You can either get an exclusive territory franchise or you can just get a franchise. Exclusive territory franchise means that if you buy, let's say that you decide to put a McDonald's in Racine. Let's pretend that we live in some alternative universe where McDonald's already is in Racine, and you decide to put a McDonald's in Racine. You can either do one of two things. You can sign an exclusive territory contract with McDonald's, which means that you're the only person who gets to have a McDonald's in Racine. Exclusive territory sometimes is just like cities, sometimes it goes very far. I've known people, I went to high school with the daughter of the person who owned the California Pizza Kitchen in our town, and they own the California Pizza Kitchen rights for all of northern North Carolina and southeastern Virginia. They had 500 square miles that they were the only people who could own California Pizza Kitchens. That's obviously going to depend on the franchise and how many franchises there want to be. I'm going to assume McDonald's is going to have fewer exclusive territory contracts versus something I don't know, a P.F. Chang's, where you only see P.F. Chang's in kind of big cities. You're not going to see two P.F. Chang's really anywhere. Or a Benihana's, they're probably having exclusive territory contracts, and those exclusive territories are probably either A, very large, or B, just for one major city, and they're not really expanding far out past those places. So now that we've explained what an exclusive territory contract is, does that have an impact on the survival of the business? And this shows us here. We're looking at whether or not somebody had an exclusive territory and whether or not the business survived. And it does not say, it says if the franchisor was classified as successful or survived. I don't know. We're not given the data of what that means, so we're just going to say whether the business was a success or not. And we're looking at if they had the exclusive territory contract or if they did not have the exclusive territory contract. So we can see here that just based on proportions, having an exclusive territory contract, just on like eyeballing this view, seems to have an impact that 15 out of 123 of the 15 out of 28 exclusive territory restaurants succeeded and 13 out of 28 failed, so almost 50% failed. While when we look at people who had exclusive territory, 108 out of 142 succeeded, or 34 out of 142 failed. So we're looking at something there that is much closer to like only 20% of those businesses failing. So that's a pretty significant difference just there. But this is just in that one sample. Can we look at this one sample and definitively say that of the 28 people who didn't have an exclusive territory contract because 50% of them failed, compared to our other group of people who had the exclusive territory contract, where only like a little bit above 20% of them failed, does this mean that there's actually a difference, or is this just a sampling error? So first of all, we're going to go ahead and establish our null hypothesis, which is there is no association between having an exclusive territory contract ignore my spelling, probably still wrong, I'm not the best speller, and success of franchise. And then the alternative hypothesis is there is an association between, and then from this point on it's the same, having an exclusive territory contract. So it's the same from that point on. So there is an association between having an exclusive territory contract and the success of a franchise. I've already plugged this table as a matrix into my calculator. And from there, I'm going to be able to kind of start talking about the conditions. So first of all, this is going to be a random sample. So we did the random sample of the 170 new franchise firms. So we check off the random sample. Since there's 170 firms, we need at least 1,700 franchises to meet the 10% condition. Since this is just talking about franchises in general, it does not talk about any specific business. There are easily 1,700 franchises in the United States. There's plenty of that. And then finally, we've got expected counts condition. When you plug this into your calculator, because this is going to be the easiest way to do it as opposed to actually multiplying and figuring out all your expected counts, it meets the large counts condition because we end up with counts of the expected counts I'm going to put in blue here. This one is 102.74. This one is 20.26. This one is 39.26. And this one is 7.74. Again, if we wanted to write this out by hand, to figure out what our chi-square statistic is, we would go through, we would do the 108 minus 102.74 squared over 20.26, or not 22.26, 102.74, sorry, I'm getting ahead of myself. (102.74) plus we would do the 15 minus 39.26 squared over 39.26, and we would do that for all of these, and we'd add them up. Once you do that, you're going to get a chi-squared value of 5.911. And we have to look here. We've got row of 2, column of 2, so your degrees of freedom is equal to 2 minus 1 times 2 minus 1, which is going to be 1. So we only have 1 degree of freedom here. So with this chi-square value at 1 degree of freedom, our p-value is going to be greater than 0.01 and less than 0.02 if we use our chart. And we actually find on our calculator that our p-value is equal to 0.0150. Now in our case, this 0.015 is greater than 0.01, so we fail to reject the null here. We say that because we're running the significance at a 0.01 level, that we do not, we are going to fail to reject the null, and we are going to say that there is no evidence to suggest that having exclusive territory contract has any impact on whether or not you're a successful business. Now, let's think about this in terms of what this means. If I am Mr. McDonald, if I am the man who is making the call on what's happening in McDonald's restaurants, when I'm trying to get people to sign franchises, and if I want people to sign non-exclusive territory contracts, then I'm going to push this data and say, look at this at a 0.01 significance level, there's really no association. So it doesn't matter if you sign an exclusive territory or non-exclusive territory contract. You run the same chance of being successful. If I'm Mr. Franchise, if I want to be the person who's opening a franchise in my local town, I'm going to say, yeah, it's not significant at a 0.01 level, but it is significant at literally all the other significance levels anyone measures at. And the most common significance level is at 0.05, so it would fail that. So I'm going to sit here trying to argue against that. So really, depending on what you would want the significance level to be is going to depend on the situation that you want to be in and where you're trying to make this argument from. So based off the fact that we're trying to run this at a 0.01%, it's not, we're failing to reject the null hypothesis. We don't have sufficient evidence to suggest this. Now again, this really depends on which side of this argument you want to take. Some people are going to argue for a lower significance level, some people are going to argue for a higher significance level. But we're assuming that we're statisticians working for the McDonald's Corporation. I'm sorry to single out McDonald's, but any of these franchise owners, and we're going to say that no, there really is no condition here. Now again, we can't use the word prove. We have not proved anything. All we've done is provided evidence. There could be other factors here. Who knows? Maybe you're in a very healthy region that people aren't going to like fast food franchises. Maybe there's something about the region that does not like the franchises. It all depends on the sample data. There's a lot of other confounding variables that we can't predict here. So because of that, we're not going to go ahead and say that it proves anything. We're just going to say that we've got pretty strong evidence towards it. All right, so when do we use a homogeneity and when do we use a test for independence? It is based on how the sampling is done. If the sampling is coming from one data source, so if we send out a survey and then we bring back that survey and then we start separating that survey into categories, we're going to use a test for independence because we've only done one sample and we're using information about the people who answered the sample to get more information. If we send out two separate samples, then we use a test for homogeneity. So for example, let's say that we were trying to figure out something. Let's say that we were trying to figure out whether or not gender influences Netflix choices. We could either do one of two things. We could either send out just one survey to a bunch of people and then ask them to indicate their Netflix preference. Let's say that it's between horror or comedy. If you had to choose horror or comedy, indicate which one it would be, send it back to us. And we just send out a blanket sample like that and all of them come back. And then we take those sample data and then we separate who said yes to horror and who said yes to comedy, and we separate them by gender. We would use a test for independence because we just sent out one sample. Now let's say that we send out the exact same question, but we send out two samples. We take a random sample of male users and we take a random sample of female users, and we specifically send out samples to those groups. So we're choosing the population of who is male and female prior. Well, then we're going to use the test for homogeneity because we've sent out two separate samples. I know that can seem a little bit confusing and a little bit confounding. Like, how does this change things? It just does. The method of sampling changes whether or not it's a test for independence or if it's a test for homogeneity. Also, when we test for difference in proportions, the chi-square test, when we're looking at whether or not there's independence or there's an association, if there's a difference in proportion, this is the same thing as a two-sided z-test. So if we're only looking at two data points, and this is only if we're only looking at two categorical variables, the proportion who say yes versus no, we can do the same thing with a two-sided z-test for an interval. So if we have two categorical variables and we're just looking at the proportion that's like a yes versus a no, we're going to end up with the same p-score as a two-sided z-test as if we do a chi-square test on it. So because of that, you can choose either or, and that's just a matter of what's your preference. I'm sure when we're taking the exam, when we're looking at questions, there are going to be things that make more sense of, okay, let's use p-score versus using a chi-square. And then finally, grouping data. When creating a chi-square test, let's say that you go through and you've got a bunch of expected counts that are working out, but then you've got one expected count that's less than 5. It might be appropriate to group those data together, and that's something that's going to be done at your discretion, and it's something that's 100% up to you. You're going to have to be able to defend it of why you can still separate that, or why you can combine that data, because there's probably going to be there was probably reasoning why we chose to separate the questions or separate the data or in the original way we did. So you need to have a good reasoning for combining the data at the end. Usually that good reasoning is going to be based on we want to run this chi-square test, and like this chi-square test will tell us something. But again, that's going to be at your discretion. You're going to have to figure out how to combine the data, and then you need to be able to defend why you've combined the data. There's a homework assignment tonight. Please reach out with any questions or concerns. Have a great night.